of 22 tons, they deliver the tomatoes to the canning factory. Here they fill the trailer with water to float the tomatoes out through a door at the side. The water, dirty from residual soil, drains away through the slats in the belt. The tomatoes land in a clean water-filled channel, and here any rocks sink to the bottom and are removed. The tomatoes float into a big tank, where jets churn up the water for a more gentle cleansing action. The tomatoes then head up to a sorting line and travel over metal bars. Smaller tomatoes fall through the gaps.
And also, MLA being a producer-funded organisation, our main aim is to provide benefit back to our producers. They're the guys that pay our levies, and they're the guys we want to reward. And I believe with the technology that we're developing to date in dual energy X-ray, where we now
Often considered to be a vegetable, the tomato is actually a fruit. It's grown from the ovary of the plant and it has seeds. It's also the most popular one on the planet. Automation of the canning process in the last century has made that possible, ensuring that tomatoes preserve their #1 slot. There are over 2,000 varieties. For canning purposes, they grow a type with a thick skin and firm consistency, so machinery can pick and sort them without damaging the flesh. Rotating clippers cut the vine as the harvester drives over the crop. Once cut, the plants travel on an elevator belt up into the harvester. Inside the harvester, metal prongs shake the tomatoes to free them from the vines. An electronic colour sorter rejects the green ones. A conveyor transfers the red, ripe tomatoes to a trailer travelling alongside the harvester. Once they have a load they'll be used to make tomato juice. The others fly on past 60 tiny cameras that detect pale or yellowish tomatoes. Pneumatic fingers knock those tomatoes out of the batch. It all happens in less than a second. Now it's the human eye that inspects the tomatoes. They send any rejects to another part of the factory to make juice. The rest take the plunge into a very hot bath. This scalds the tomatoes and loosens the skins. The tomatoes then travel on a moving bed of rubber discs, and this gently pulls the skins away from the tomatoes. A spray of water washes away the skins, which then fall through the rubber discs. This ensures no mess is left after peeling. The now peeled tomatoes travel onto another conveyor, where sprayers give them another rinse. This conveyor controls the flow of peeled tomatoes into the processing room by metering the produce as it moves forward. Ahead, the dicer waits. It has 3 sets of cross-cutting blades to make light work of the tomatoes. The tomatoes tumble down a chute into the dicer and are chopped into small cubes. The diced tomatoes pass workers who pick out pieces that aren't perfectly red. They also remove any pieces of core. Leaving the cleaning station, the cans queue up for a fill-up. Ahead, the diced tomatoes flow into metal pockets. This portions them out, ready for the cans. The pockets rotate forward to meet the cans, now moving in sync below, and the bottoms of the pockets open to release the contents into the cans. They add hot tomato juice and flavourings. Lids advance towards the open cans. They land on top, and a machine crimps the lids to the cans, creating a double seam for a complete seal. Now in airtight cans, the tomatoes head into a hot oven for a quick cooking, which sterilises them, removing the need to use preservatives. The cans now get their labels. They spin across wheels that apply glue to the sides, and then roll over paper labels which adhere to the glue-covered cans. Here's the labelling action slowed down. The label contains brand and nutritional information, as well as the exact time of production. This means it can be traced if there's ever a quality issue. It's taken about 1 hour for these tomatoes to be harvested and canned. All that's
Scott Technology has been automating processes for over 40 years now. We've taken that substantial history and commenced automating meat processing systems. And in partnership with JBS and Meat and Livestock Australia, we've developed the world's first lamb X-ray primal and middle system.
What we're seeing so far are benefits in reduced labour input in processing plants and also in improvements in yield. And I think the improvements in yield are the really exciting part of this technology because of the improved accuracy in cutting primals and extracting value out of the carcass. What we're seeing from the processors that are investing in this technology is that they're able to pass back some of those benefits to producers in terms of improved pricing.
I believe MLA needs to be the strategic driver in this technology, along with our processing partners, our technology providers. Producers now will be able to be paid for what they provide to the processing organisations.
At the end of the day, this equipment really places high value parts of the animal into those high value cuts. And that's the whole purpose of that X-ray primal machine. At JBS Bordertown, we've also got our middle machine. And that takes the middle section from the primal machine and then further cuts that into really high value cuts. So it generates a rack and a loin, which then enables you to remove a chine bone and do French racks. Independent economic analysis by Greenleaf Enterprises has identified that safety is one of the many benefits that this equipment provides. Although, touch wood, there are not very many bandsaw injuries in the industry. When a bandsaw injury does occur, it is quite severe. People lose fingers or worse, parts of their hand. By putting in this system, it eliminates that from ever being able to happen again in the future.
When you're trying to do transformation, you've got to find the players who will go out on a limb and actually do something different, because it's very easy to do what we've always done. And I think in our industry there's a lot of history. You know, our values are tied up with livestock and how livestock have always been raised and slaughtered. I think in terms of JBS, they're a worldwide player and they've been able to look at this and say, hang on, we've got to take some cost out of this system because we're a high-cost country. And so they've really been able to also put their skin in the game and co-invest through the donor company with the taxpayers in Australia with matching funding to get great outcomes.
I think the first one, it was a good thing to have R&D support through MLA. It obviously reduced some of the risks. Of course, the real risk factor was that it didn't achieve what we thought it was going to achieve, and the payback blew out beyond our expectations, and it wasn't reliable and all those sorts of things. It's almost 2 years to the date now when we started the first part of the install, which gives us a good foot to go forward in the next model. Certainly we'll be looking to develop other areas of carcass processing on land.
We're continuing to work with Meat and Livestock Australia and JBS and ALC to finish off our current developments in the area of automated forequarter processing and automated hindquarter processing. And I believe it's only 12 to 24 months before I can come back to this plant, or I can go to ALC Sunshine and I can see those last remaining pieces of the puzzle installed in a boning room and running. And that's when we'll truly see a room as efficient as it possibly can be.
Next stage of the investment from MLA and development from our key partners, and following on from the commercialisation and adoption of this lamb boning technology, we'll be taking the key learnings and rolling it into beef boning. The challenges in beef boning are going to be more complex, but the rewards will definitely be greater through cut accuracy and yield benefits.